where are we? Good. Okay. So you all remember standardized formula in Excel? Standardized. अरे खुशी कहाँ गई? बोलो. Standardized is equals to standardized. We did not is equals to norm.dist we used.
Yes.
Norm.dist we used. You remember? But we use is equals to standardized also in class. So what I will do is maybe I'll revise things in first 10 minutes and then we'll go ahead. Okay. All, let me actually revise everything that we have done till this date from day one. करें 5 minutes. पूरा revise करें पूरा. Okay. So we started our discussion with the definitions of statistics, data, variable. Remember?
Yes.
Right. अगर कहीं पर भी याद ना आए तो मेरे को बोल देना कि ये मुझे याद नहीं है कि क्या definition थी या what was it? Can you repeat? So I'll repeat also. Right. So we are revising as in we are just talking about the topics and so that will help you remember what all topics that we discussed. So we started the discussion with the definition of statistics, variable, data and all. And I told you that there are actually two kinds of statistics. Descriptive and inferential. There can be third leg of statistics also, which is known as predictive statistics, where you have regression. In inferential, you have your z-test, t-test, and all the other hypothesis sets. In descriptive, you have your numerical and pictorial representation of data. In the pictorial or graphical manner, we had the pie charts, histograms, bar graphs, and all. I gave you the slides and I asked you to go through it. In the numerical descriptive statistics, we had measures of central tendency, mean, median, and mode, where we discussed that mean is something which is very much affected by outliers, therefore median is better. Mean and median both are not able to take care of qualitative data, that is why mode is also important. Mode can be used on qualitative and quantitative both. Then we start talking about measures of dispersion, where we discussed range, where we discussed standard deviation, variance, and we also discussed coefficient of variance. Then we moved forward and we started discussing, after discussing standard deviation and other things, we started talking about skewness and kurtosis. You guys remember left skewed, right skewed, positive or negative? Left is positive or negative? Left skewed is positively skewed or negatively skewed? Negatively skewed. Right skewed is? Positive. In a positive skewed data, mean is higher or median is higher? In a positively skewed data, which is more? Mean is more than median or median is more than mean? In a positively skewed data.
Mean is more than.
Mean is more than median, that is why it is known as positive, which means that there are outliers on the higher side. Then we also talked about kurtosis, leptokurtic, platykurtic, mesokurtic. Platykurtic is when there is a plateau forming up, the peak becomes low, the tails become thick. Right? There are more values on the extreme, standard deviation is way too high. Leptokurtic means that the peak is very, very high. There is not much data in the wings, and because of that, most of the data is around the mean. Mesokurtic is what is normal. For skewness and for kurtosis both, the range is from -3 to +3. Right? Then we started talking about, after this we started talking more about distributions, where we discussed that also, before this only, we talked about data. We talked about data as in the data can be qualitative, quantitative, then the data can be categorical, right? And in categorical, you have nominal and ordinal. Nominal is for the namesake, ordinal is where there is rank ordered data, right? There is rank. Then we also talked about continuous and discrete. हाँ या ना? कुछ लोग नजरें चुरा रहे हैं. नजरें चुरा रहे हैं मतलब कि उनको याद नहीं. उनको क्या अपने को नहीं ऐसा याद करना है, स्लाइड्स पढ़ना है बेटा. हाँ जाना है वापस स्लाइड करना है. So you have continuous and discrete data. Continuous data is the data where you cannot exactly pinpoint at a particular value. It is continuous, right? Uncountable. Discrete is something which is countable. And we also discussed ratio and interval scale. Ratio scale is where absolute zero is nothing. It is zero, right? Whereas in interval data, absolute zero also makes some sense. For example, you're talking about temperature, CAT score, RAT score, whatever. Then we start talking about distributions. because we had a good understanding of continuous and discrete data, we said that we will do two discrete and two continuous distributions. In discrete, we did binomial and Poisson, right? Binom.dist, Poisson.dist. Binomial is the kind of distribution where there are only two possible outcomes. One of them is termed as a favorable outcome or success. Other one is termed as a non-favorable outcome or failure. The probability of success plus failure is 1. If the probability of success is P, the probability of failure becomes 1 minus P. You do n independent trials. What data you get will be a binomial data. And we talked about cumulative yes or no, true and false, right? And binomial also. 0 to a certain value. 0 to a certain value is cumulative. If I have to find out the probability above this, so I'll say 1 minus 0 to this. This we did. Then we started talking about Poisson. Poisson distribution is a distribution where you are given a mean occurrence rate in a specific time period. And you are asked the probability of a particular event happening in that particular time period. दादा ये ऐसा कुछ होता था, 1 घंटे में एक रेस्टोरेंट में ऑन एन एवरेज 22.5 लोग आते हैं, तो बताइए कि 13 लोग आने की प्रोबेबिलिटी क्या है, निकाल सकते हैं जी. X is 13, lambda is whatever number I said, and then you do it. That was Poisson. So these two were discrete data, where the number of people coming in is discrete, the number of successes and failure will be discrete. Then we started talking about continuous data, where we discussed uniform distribution. And then we started discussing the most important and the most commonly used distribution, which is normal distribution. In the normal distribution, we started our discussion with defining a normal distribution. Defining a normal distribution means the two important statistics in normal distribution, mean and standard deviation. भाई पहले तुम बात कर लो, तो आराम से करो. नहीं अरे मैडम हो गया. ये क्या है? Doing all this in class is bad. That's a good. मतलब you are doing good. Okay. Remember the first rule. Roasting is allowed. कोई बुरा नहीं मानेगा. You can roast back. It's okay. मेरे को बोल सकता है you. Okay. Then we were talking about देखो तुड़वा दिया flow. मैं रट के आया था. Okay, so we were talking about normal distribution, where I said that you define a normal distribution using mean and standard deviation. Mean is mu, standard deviation is sigma. Then we start talking about normal standard distribution. Normal standard distribution is a case of normal distribution where mean is 0, standard deviation is 1. Wonderful. Why do we have this standard normal distribution? Because the standard normal distribution helps us find probability at any point. So if I know the probability, now from here only we'll start. Then we'll just make sure that these things are clear to us. So I told you that doubt कुछ पहले.
एक practice questions में there was a discrete or continuous variable returns on Amazon.
Okay.
Discrete or continuous, I think.
तुम बताओ.
Discrete.
Doubt कहाँ है? DCP नंबर कहाँ है? DCP पता है तुम लोगों को क्या होती है? तो जैसे क्लास पार्टिसिपेशन के मार्क्स होते हैं. हाँ वो सही बोला भाई. जैसे क्लास पार्टिसिपेशन के मार्क्स होते हैं तो कई बच्चों को ये लगता है कि and that too in a specific institute where there everybody is running a race to get more marks. तो लगता है कि अगर आज मैंने पार्टिसिपेट नहीं किया क्लास में तो मैं पीछे रह जाऊं. डाउट. नंबर ऑफ रिटर्न्स and number of returns भी 12 point. तुमने कभी कोई सामान आधा हाँ कर सकते हो अगर मन में खोई. ये सवाल बहुत अंदर से आया है. You got it right.
Yeah.
Number of returns will be.
But it's discrete only, but Google.
Google की बात है. Google खुद को नहीं पता कि वो discrete है continuous है.
Liters of water in a bucket.
Liters of water is obviously continuous. Google discrete क्या है?
नहीं मेरे को discrete लगा था.
अच्छा, liters of water in a bucket. See, volume will always Abhi aapse, if I am asking, and we discussed this in the class also, if I am asking you how much water is there in this bottle, now you can say that the bottle is 1 liter. But exact amount of water, nobody can tell. Right? We can only measure this to the extent where we have the measurements. Right? अगर मेरे पास में ml तक है तो मैं ml तक कर रहा हूँ, but ml को भी तो और break down करके, so I'll never ever be able to. But if you are saying that the way you're defining the variable is very, very, very clear, which is 1 liter, 2 liters, 3 liters. Now, even if you're saying 1 liter exactly, nobody can exactly measure 1 liter, right? Same is for weight, same is for second. Okay. Okay. So,
DCP
नहीं था वो, it was CP. He had genuine doubts. Submit कर दिया?
डेडलाइन था
Deadline था?
किस चीज का?
डेडलाइन
एक बार डेडलाइन चली गई.
डीसीपी का फुल फॉर्म सेंड करता हूं
अरे DCP is desperate class participation. Sorry. How many of you have not submitted?
आप खड़े कर
Where were you?
questions. नहीं आज का आज ही
उसी
हुआ
दिन
है.
सबमिट कर
Online, how many of you have not submitted? Raise your hands.
Online. Online.
I don't think that पाओगे submit. Okay. Asim, only one person has not submitted. Then it is fine. Those who have not submitted, let them submit with -4. जितना भी है.
चार ही तो नहीं टोटल.
तीन नहीं होना चाहिए, नेगेटिव हो जाएगा. 7 क्वेश्चन है.
चलो एक काम करते हैं. But the deadline was yesterday, right? For every day, for every 24 hours that you are getting late, we'll reduce 2 marks. एक दिन लेट हो तो 2 मार्क्स, 2 दिन हो तो 4, किसी को 10 दिन बाद सबमिट करना है तो 20. ओके, गलत थोड़ी नहीं, ठीक है, दिस इज ओके, राइट? डोंट लाइक दिस.
कंसेशन नहीं
बताओ कितना करना है? फॉर एवरीडे 1 मार्क.
दे दो
Extend कर दे,
दिन तो दो,
deadline.
ऐसे फ्री वाले दो दिन तो फिर माइनस. सर हमें भी तो टाइम नहीं मिला था.
yesterday EOD.
टुडे कर दीजिए टुडे
टुमारो सर टुमारो. आज तो 7 बजे तक क्लास ही है सर. अब कहाँ करेंगे?
Today 1 marks, tomorrow 2, day after tomorrow 4.
एडिशन
Fibonacci.
अब दे क्यों रहे हो सर? अब मार्क्स हम तो
आज YouTube डेटा वाले के
चलो.
सर तुम कर ही दो. 1 मार्क दे रहा हूँ.
Yeah, I know you will do it.
Sir, in general, for practice questions, do you just want the answers with the questions, or Excel format, or do you prefer something specific?
If you are doing it on Excel, give the screenshots of the Excel. And if you're solving it by hand, you submit the photo.
For example, now we've submitted just the answers Excel में करके Excel submit नहीं किया. Can we do the Excel again?
You have to.
will focus on
You have to.
सर फिर भी फॉर्मूला डाला है फिर आंसर डाला पहली बात
And वो
डाला है?
बहुत ज़्यादा मेहनत करिए.
नाम से बनता है.
Okay. So we were talking. So let's say you have a normal distribution. Every normal distribution is defined using mu mean and sigma standard deviation. Now I want to find out the probability at a specific point. I don't know how to find out the probability here. For this, what we do is we convert this to a standard normal distribution. Standard normal distribution. In this standard normal distribution, what happens is mu is 0, standard deviation is 1. And I have a table which tells me the value at all these points wherever I want. So I have a table where I have a z value. I can look at the z table and I can find out what is the probability at that particular point in time. It starts from z is equals to minus 3.9999999 and goes up to 3.999999 on the positive side. I am going a little fast because we have already done this. Right. For your reference, I will just show you how the z table looks like. This is not a z table. This is what Z table looks like, right? So it starts from almost negative 3.99 and goes up to positive 3.901 to 34678 so 3.99, right? These are the values that you have. And let's say I want to find out the probability at z is equals to 1. So I will just go and see where is z is equals to 1. So the probability is 0.84134. And we also did a few examples on the height data in the class. If the average height is let's say 5.5, standard deviation is 0.5, what is the probability of finding somebody with height less than this, more than this, in between this and this? We did all that, right?
Yes.
We also said that there's a formula for z, which is z is equals to x bar minus mu upon sigma by root n. And then we said that we don't need this formula. Actually, you can actually find the standardized value on Excel using the standardized function. That is for population actually, not this, only this. And then in order to find out the p-value that you are doing from the table, that also you need not do, you can actually do it on Excel easily. And then after this, we started talking about the hypothesis testing. Also, I told you that sometimes when z is not available, when sigma is not available, we use another kind of table which is known as a t table. We looked at the t table also. We know how t table and all works. So this was what we had in t table. What you have is the degrees of freedom. You look at the degrees of freedom and you also look at the probability, and then you find out the value in the t table. And then we started discussing hypothesis testing, where I told you that hypothesis is nothing but a testable statement. There are two kinds of hypotheses that you have. One is null and the other one is alternate. The null hypothesis will always have an equal to sign, right? And the null hypothesis will never ever have an equal to sign. Did we formulate hypothesis in class? We did a few examples. Okay, let us do it now and see how are we doing. Let's say I am Dyson. Dyson claims that they make air purifiers, and the air quality index in the room where Dyson is put will be at most 70. What will be the hypothesis? Dyson is claiming that if you put our air purifier in a room, the AQI will be at most 70. At most 70 on an average. क्या होगा जी? Null hypothesis क्या होगी? At most 70 means maximum 70. That means 70 and
equal to.
Less than or equal to
so
7.
mu will be less than or equal to
7.
and alternate will be. Now let's say that let's say
Master Civil.
let's say Red Bull says that the caffeine percentage in our bottles is at least 75 mg per 250 ml. So let's say at least 75 mg. At least 75 mg. What will be the hypothesis? So mu is greater than or equal to 75. And alternate will be that it is less than 75. Let's say MU says that we have 50 students in each class. 50 students in each class. So they're saying, they're not saying that we have at most 50, at least 60, 50, whatever. They're saying we have 50 students in each class. So the hypothesis will be mu is
Equals to
50 and the alternate will be that it is not equals to 50. Then we started discussing their diagrams also, where I said that this is these two. First two are one-tail tests. Remember?
left turn.
One tail, and this one is a two-tail test. First one is the case where if the AQI in the room, Dyson is claiming it to be 70 or less. So if the AQI is 70, Dyson is doing good. 60, better. 50, even better. 10, very, very good. So you will never have a problem on the lower side. The problem will arise only if the AQI is high. So this is a upper tail test or a right tail test. upper or right. In the second case, when Red Bull is saying that they have at least 75 mg of caffeine, so it is 75 or higher. The higher it is, the better it is as per their claim. So the problem will only arise on the lower side of the things. And when MU says that we have 50 students in the class, we'll have problem if the students are way lesser than 50 also and way more than 50 also. So it's a two-tailed test where the rejection region is on both these sides. Till this point also things are fine.
Yes.
Right? This we discussed already. And then we said that, okay, how do I decide on this particular value? What is this particular value beyond which my rejection region starts? What is this value beyond which my rejection region starts? How do I find out this value is the question. And we say that this I will start calling as the critical. This is the critical value beyond which my rejection region starts. Similarly, here also, this is the critical value beyond which my rejection region starts. This and this also will be the Z critical value. Right? Till this point also, things were fine. We also discussed that this critical value and the rejection region and all these things are dependent on a few things. It is dependent on the standard deviation, right? The higher the standard deviation, did we discuss all this? Did we do questions on hypothesis testing in the last class?
We did a question.
So we were till here
I
only.
think critical values.
Okay, so we were here only. Right. So we said, okay, if I'm talking about 95% confidence level, the area here will be 95%. Whatever is left is 5%. So this is 5%. This we discussed. Right. So if I'm talking about 95%, this area is 95%. This is 5%.
I think we discussed it normally with normal distribution, but not specifically.
Okay.
Hypothesis.
But then this is logical. If I'm talking about 95% confidence level, whatever is shaded will be 5%. The rejection region is 95. This is 5. And now if this is 95. How much will this and this be? 2.5% and 2.5%. Wonderful. Now let us start from here. Now, in a way, let's take the first example where Dyson is saying that the AQI is less than 70. On an average, I have written mu. Mu is less than 1, and I want your attention for the next 10-15 minutes. We will have intense discussion. After that, if you want, I am ready to give you also. For 2-3 minutes. But this 15-20 minutes, I want utmost attention. So, in the first case, when Dyson is saying that the AQI will be less than or equal to 70, less than or equal to 70, on an average. Now, let's say I have 100 rooms. In every room, I have put a Dyson air purifier. Right? Now, depending on a few things, such as whether the window is open or not in the room, whether the size of the room is big or small, the number of people sitting in the room, how dusty was the room before I put the purifier and all. The air AQI level, the AQI level will be different in all these rooms, depending on a lot of factors and all. And out of these 100 rooms, I go and pick samples. Let's say I pick a sample of 5 rooms. Now, by chance, because of the biased nature that I have, I picked the rooms that were bigger in size. Right? Bigger in size. If the room size is bigger, the purifier will take a little more time to purify the air. Right? And there I saw that the AQI was 72, 70, 71, 72, 71. So what is happening is I will find out the average which is higher than 70. So मुझे बोल देना चाहिए कि Dyson झूठा. I should say that, right? But Dyson will come back with a claim saying that you took samples. These samples were biased samples, right? And it is not a very good way to take samples. What you've done. We never claimed that in each room the AQI will be below 70. We said on an average it will be below 70, equals to or below 70. So which means that in some of the rooms it will be 60 also. In some of the rooms it will be 72 also. Average will be below 70. What you've done is wrong way of taking the sample, and because of that I am having this problem. Possible. How do I rectify this? And on what basis do I decide this value, this Z critical value that you are talking about? beyond which, if you are going in this region, beyond which you will start saying that Dyson is a liar or the claim is rejected. How will you decide this? How will you decide this is the question. Right? Now, in order to do this, in order to find this, and I've told you clearly that I want to be 95% confident. 95% confident, which means that the value which is here is 5%. All of us can now find out the Z critical value at 95% confidence level. We can go to the table and we'll see what is the Z value here. Let us very quickly, you want to see or you remember the value?
We'll revise.
You'll see, but you need to remember also, okay? I'll show it once, but then you remember this value, 95% confidence level. 95. 95. Where do I get 95? I know where do I get 95, so I can just go to that directly. 1.6, 0, 1, 2, 3, 4, 5. Right? 1.65 is where I get 95%. 0.95 is 95%. So I can tell you that this value is 1.65. Similarly, on the lower side also, it will be opposite of that exactly negative. So it will be negative 1 point. But it will be a little different in this case. Why? Because this is area is 2.5%, which is 0.025. Right? Where do I find 0.025? It will be at 1.96. I'll show you. Negative 1.96. 0, 1, 2, 3, 4, 5, 6. 0.05. 0.025. Right? So this will be negative 1.96 and this will be positive 1.96. I found out the Z critical values. Now, what are these Z critical values? These Z critical values are telling me that sorry, somebody said something online?
वो बगल वाले क्लास है वाला
Acha. So this Z critical value is telling me that if you feature beyond this Z value, I will reject. And I am giving you a tolerance. See, you claimed 70, your claim was 70. अगर वहां से आवाज आ रही है तो मेरी और भी तेज है. If your mean is 70, I am giving you a tolerance that okay, there might be sometimes sample bias, this and that, because of which I am giving you this much of tolerance. You can go to this side and still I will say that this is just by chance that you have got to this 71, 72, right? And there is a possibility that if I take more samples, I can come back. But if you go beyond this, then this is not by chance. Then there is something wrong in the claim. But my sample, let's say the 5 samples that I took are giving me a AQI of 200. Then Dyson will not be able to tell me that no, the room size was bigger, the room was just this. I said, we have 200 is, so your purifier is not working. So how do I decide this is one thing? Right, for this 70, I have already found it out actually. If I know Z critical, I can easily find out this. If I know other things. So this is one thing where you need to talk about the Z critical value. And then, so you have the Z critical value which says that, okay, in order to be 95% confident, you need to be featuring here. Now, I will also be given more data, such as Dyson will also tell me that the mean is 70 is our claim. And our air purifiers generally have a standard deviation of, let's say, 2. I took a sample of, let's say, 100 purifiers and I got an X bar value of 72. Possible? Now, with this information, I can test this hypothesis. How do I test this hypothesis? This Z critical is given. I can find out a statistic is known as Z calculated. I can calculate a Z. How do I calculate Z? All of you know the formula. Formula is X bar
plus T alpha.
X bar minus T नहीं Z. X bar minus mu upon sigma by root n. So what is X bar? X bar is what I found out 72. What is mu? 70. What is sigma? 2. What is root n? Root of 100. Right? So what will be the answer here? I am solving it here, right? 72 minus 70 is 2 divided by 2 upon 100. 2 upon 10 is what? 0.2. 2 by 0.2 is how much? 10. The value I am getting is 10. 10 is very, very high, which will be here somewhere, right? 10 is very, very high here somewhere. So this Z calculated, in this case, the Z calculated is somewhere here, whereas Z critical was here. Z calculated is coming out to be 10. Z critical was only 1.6, which means that I am playing in the rejection region. ये वही वाली बात हो गई जो मैं 200 आ रहा है, 200 आ रहा है, because you are saying that the tolerance is very, very low. And you are featuring in a region where you have taken a very high sample also and all. Because of that, you are in a region which is a rejection region. So you will say the Dyson's claim that the AQI is less than or equal to 70 is getting rejected. Yes, sir.
What is the difference between the Z formula and the T formula then? Because I thought the Z formula was अपना x bar minus mu divided by standard deviation और T का था was divided by standard deviation divided by root of n.
Formula was same for both. यहाँ लिख दूं T का यहाँ लिख दूं T का तो लिखा ही हुआ है T फॉर्मूला T for ये बोल दो T formula is the same. The only difference is x bar minus mu divided by s by root n. So T is s by root n. Sigma is standard deviation of population. S is standard deviation of sample. So in T you take standard deviation of sample. In Z you take standard deviation of the population. Right? Now, did you understand how did we take this decision of rejecting or not rejecting the hypothesis? पूछो.
बस वही था Z value comes in sample and T value comes in population. That's the
No. T value is used when you have population standard deviation, sigma. When sigma is given, use Z. When sigma is not given, use T. Right? Okay, ji. Everybody is fine with this. There are multiple ways of looking at it and doing it. One way of doing and looking at it is this one, where you had a Z critical value, you calculated a X bar value. With that X bar value, with this specific X bar value that you have, with this specific X bar value that you had 72, you calculated a Z calculated, and then you compared Z calculated and Z critical and you reached to a specific conclusion. One more thing I can do, which is that I could have found out this value with respect to Z critical. How do I find out this value with respect to Z critical? See, Z critical is 1.65. I can put 1.65. Let me use my. So I can say, my handwriting will be bad now, huh? Because I'm using my. So I can say Z is given 1.65. 1.65 is equals to X bar minus mu. I want to find out the X bar value. X bar minus mu is 70 upon sigma by root n. Sigma is 2, root n is 100, so it will be 0.2. 0.2. 0.2 into 1.65 is how much? 0.2 into 1.65.
0.33.
0.33 is equals to X bar minus 70. X bar will be how much?
70.33.
X bar is equals to 70.33. You get it right? 70. So So now any value of the sample
Divided by-
which is higher than 70.33 will be rejected. So I am just giving a tolerance of 0.33. ये जो tolerance की हम बात कर रहे थे, this tolerance is only 0.33. If your sample is below 70, very good. On the higher side, I am only allowing you to go up by this much, which is sort of an error only I am saying in sampling. मेरी सैम्पलिंग में कोई एरर हो सकता है छोटा मोटा जिसकी वजह से 0.33 का टॉलरेंस मैं आपको दे रहा हूं. If you go beyond that, then that is not sampling error, Baba. There is a mistake with your product.
इसमें
पूछने के लिए भी नहीं आ रहा. दोबारा बताते हैं.
सर
एक
एक
वाले के साथ समझते हैं.
वही है sir, मतलब now when we say 70.33 like 72 जो आप बोल रहे हो एवरेज, that was not what Dyson claimed, that is what I claimed कि मुझे 72 एवरेज आ रहा है suppose.
तो आपने क्लेम नहीं किया तो आपने उसी में से सैंपल लिया था. डायसन का मान लीजिए कि एयर प्यूरिफायर आई एम यूजिंग इन थाउजेंड्स ऑफ रूम्स. Randomly I picked any 100 rooms. So Dyson, I am a big institution, let's say like Masters Union, where I have 100, 500, 1,000 rooms. Right. I am Google, who has thousands of offices. Right. Now I put a Dyson air purifier in all my offices. Now Dyson, when they sold the product to me, they told me that the AQI in all the offices will be below or equals to 70. I said, fine. I wanted, one day I thought that the AQI is not what Dyson claimed. And I wanted to test whether what they had told me is true or not. So I floated a survey. And I told my employees that you tell me how much is the AQI in your office. Now I got the survey where I got a survey from 100 employees. Now these 100 employees are saying that our AQI, somebody is saying is 70, somebody is saying it is 68, somebody is saying it is 74. I found out the average. The average that I got was 72. So I called Dyson and I told Dyson that the average is 72, which is way higher than what you are claiming. So Dyson says that there is a sampling bias. Only those people have responded who are getting a bad sample or a bad AQI higher than 70. Mostly they are responding. I tell Dyson that, okay, possible, right? Let us be 95% confident and talk about it. So I did my calculations. My calculations tell me that, okay, error in bias, error in, the sample and all will be considered only if the average is below 70.33. If it goes above 70.33, critical value, then Dyson is not true. Dyson is lying. Something.
So you were 95% confident that Dyson is lying.
I am 95% confident that with this sample, I will reject what Dyson is saying or Dyson is not claiming true things.
So, in practicality, is 95% the average confidence?
Good question. 95% is the gold standard generally in manufacturing and services, but it depends on industry also, and it varies industry to industry. Generally, for defense equipments, for space exploration, or pharmacy, this is very high, 99.99 also, right? Because the tolerance has to be very, very low. In fact, for manufacturing also these days, the tolerance is very, very low. So if you're a car manufacturer and you're claiming that I am making a reusable part, a reproduce a repeatable part or a reusable part, let's say in your car brake pads हर कोई बदलवाता रहता है थोड़े टाइम में. Now the brake pads manufacturing system has to be such that the brake pads are exactly the same dimension. If the dimensions are not the same, then there will be a problem in fitment and all. Replaceability will be very, very low. I want my brake pad highly replaceable. Now they say that the dimension of our brake pad is, let's say, 20 mm. Right? And then when you do sampling, so now let's say, what are the companies that manufacture brake pads? Sriram and this and that and all. Huh? Thank you. So let's say the locks and the keys and all, Minda is the company that makes it. You guys should invest or what? Okay. So you are making these brake pads, and then you find out that the company is claiming that the brake pads dimension is exactly, let's say, 50 mm. Now, the tolerance that will be there will be very, 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 very low. The company will tell you that we manufacture brake pads with 50 mm length, and the standard deviation is only 0.01 mm, plus minus 0.01 mm. Now, what do I mean here? Let's take this example only, okay? The one that we are looking at. Let's say we were taking MU's example. Now we are changing this example to brake pads. Now, the company manufacturing brake pads tell us that the average size is 50 mm with this is 50 with a standard deviation of 0.01. Okay, with a standard deviation of 0.01. Now you want to check whether this is true or not. You take a sample of, let's say, 25 brake pads only. You take 25 brake pads from them, and what you observe is that the X bar value is 50.02. We're talking about very, very, very low margins here. See, and when we're talking about MMs. So what you took 25 of their brake pads, and you measured their the size, and you found out that it is 50.02. Now whether you will accept or reject their claim is the question. Let us see. Right? And they're manufacturing thousands. Out of those thousands, you have just randomly taken 25. Now you will say that, okay, the Z critical value was 1.96. Z critical was 1.96. Let us find out Z calculated. हाँ? इधर आएगा.
You can see.
So, visible now. So I want to find out the Z calculated. Z calculated will be X bar minus mu by sigma by root n. What is X bar value? 50.02. What is mu? 50. Divided by sigma, that is 0.1. 0.01. Divided by root n. Root n is what? 25 root, which is 5. Can you solve this for me? 0.02 divided by, what is 0.01 divided by 0.5?
002.
10 आएगा.
0.002.
002.
You remove this, then you divide 2 by 0.02, which is, now the Z value, subject 10 here. Now the Z value here is 10, which means that you are way above, way beyond the Z calculated is here. That means you are way beyond this critical value. That means you are in the rejection region. Now you are saying that no, the brake pads that you are manufacturing are actually not 50 mm. They are a little higher than 50 mm. And it is not 50 mm. And believe me, these are not even real numbers. Real numbers are even more stringent. You talk about standard deviation of 0.000. You talk about, confidence of more than 98, 99%. Right? So the manufacturing processes have gone to that extent where the variability in between these parts is almost zero.
So one question.
Yes.
How do we get the standard deviation?
Oh, yes, wonderful. Now, and this is the most important question here, that how do you get this sigma value? Because you are saying that this is standard deviation of the population. आपको पूरी population का standard deviation पता ही है तो आप क्या ढूंढ रहे हो? What we say is that this is on the basis of the historical data that I have. Right? So let's say Sundaram fasteners or Sundaram brake pads, they've been making brake pads for 50 years with the same machines and everything being the same. Now they tell you that in our machine, the capability of the machine is that it is producing what it has to produce with a variability of only 0.1 or 0.2. ये तो machine की capability है ना, तो ये वहां से आ रहा है. Historical data or the capability of the machine is where it is coming from.
And how will we get to know when we test this hypothesis that this is
Generally, the machines that are there, generally their production system, they'll be able to tell you. For example, let's say you're talking about Natraj pencils, right? Natraj pencils are there. When you see the box of pencils, and if you use your finger also, you'll feel that all the pencils are same height, right? Sometimes, very rarely, you'll find that one or two pencils are a little smaller or a little larger than what the other pencils are. Right? That is the variability. Now they'll be able to tell you that if you are manufacturing 1,000 pencils, there'll be little variability in one or two pencils. Why? Because the tool that is used to cut. So pencils are made in one way and then they are cut together in batches, right? So the tool that is used to cut gets blunt over some time. And उसकी वजह से 0.001 का variability आ जाता है. So that will be told with the process. The manufacturer has the tools and all, and they know that historically the tool that we've been using will give a variability of this much over these many products.
So maybe Dyson will have, but not us. So in that case, Dyson will be the one who can test this hypothesis.
No. So the thing is, if Dyson is giving you this information, if they are ready to give you this information, and if you have this information, you will use a Z test. If Dyson is not giving you this information and you don't have this information, then you will use a T test because you can get this information from the sample. आप ये भी तो बोल सकते हो कि मैंने 1000 पेंसिल टेस्ट करी या मैंने डायसन के 100 एयर प्यूरिफायर्स I have tested. In these 100 are where am I getting these 100 from? I am getting these 100 from the population. This is a very good representation of the variability in the population also. आप मत बताओ, मैं खुद पता कर लूंगा. There I will be using a T test.
So, last change.
Yes, please.
When we, I understand Z value, how it comes in, but when you're trying to show it in the graph, this is the curve and from this the Z value is stretching, then it's.
Okay, when it is
Can
going
you just
for-
show how it goes, how the Z value is placed in the
Right. For that, if you allow, either I'll add one more slide. Let me add one more slide. I need to have a blank slide. Okay. Okay. Now, okay. Now I will do it on a bigger scale, and I think we'll be able to address the doubts here. Is this my mean? I also have a standard deviation. Yes, sir.
Also, the minimum confidence with which we can produce products is 50%, right?
No. Generally, anything below 90 is not accepted. On the higher side, it goes up to 99.99 also.
In the Z and T tables, why are there confidence intervals of 50%?
These are the area, in the Z table, what you have is area covered at different Z values. These are not confidence intervals. The Z table does not prescribe any confidence level. It just states what is out there. So it is for you to use, but it does not say that, we don't have any minimum, we don't go below 90 generally, right? In research, in social sciences research, we generally settle down at 95. 90 also in marketing research, we generally say that, okay, with 90% confidence level, I'm able to say that product A is better than product B. In consumers mindset at least. But anything below 90 is generally not accepted. अब इसको एक बार समझ के देखते हैं यहाँ हो क्या रहा है, ठीक है? यहाँ पर मैंने I have made a claim that my value of mu is, let's say, 70. That's an example only. This is what I'm claiming it is. And I'm claiming that the value is not only 70, but it is anything which is less than or equal to 70. Anything which is less than or equal to 70. Which means that if the value is starting from 0 and is going up to, let's say, infinity, right, I am happy with something which is 0 also, and 10 also, 20 also, 40, 50, 60, 70. Right, I am claiming that I am here. I am here is what I am claiming. But what we say is that, okay, you are claiming that you are here, but then if I am taking, and let's say they are saying that the standard deviation is 2, is what we said, I think. Right, this is what they are saying. Now, we say that, okay, to test this claim, and they have put, I am Google, they have put purifiers in thousands of my offices. I want to test this. In order to test this, I take a sample of 100 is what we will see. And we found out the X bar value of 72. Right, this is what we were doing.
So just basic question. When you say standard deviation is 2, that means in 72, 68% of covering all the 68% cases, something.
अब वो वाला भी देखते हैं. तो आप कह रहे हो वो देख लेते हैं. So what you are saying is 72 to 68. One standard deviation here and here. This should cover 68%. That's what normal distribution says. But whether this is true or not, we don't know, because we are testing whether it is actually 70 or not, first of all. But what we are saying is, in an ideal case, generally by rule, that is true. That is what it is. If you are having problem understanding what this standard deviation of 2 mean here, right? So this standard deviation of is nothing but they say that the average air quality index will be 70. Sometimes you might find 68, sometimes you might find 72. 68% of the times you will be finding it between 68 to 72. That's what standard deviation is meaning here in real life. Right. Now, after this, what you do is you go and you want to test whether this is true or not. Now you say I want to be 95% confident on what I am testing. Now, 95% confidence means what? So you will say, and if you remember, I told you earlier that this critical region that we get. So let's say I am talking about this critical region. This is the critical.
Sorry, I'm stopping you again, sir. This 72 has been given to us, has been assumed.
No, we calculated it from the data.
That is from the 100 samples.
Right. So when I survey fruits here and 100 people have responded, the AQI in their room. So these 100 people, I added X1 plus X2 and X for all 100 offices, and I got it to be 7200 divided by 100, and I got 72. This will not be given to us generally. We will calculate it always. Right. But I am assuming that we know how to calculate, so we are just skipping that part. Now, and this will be given. This will be given by, like you was asking, this will either be given by Dyson to us, or this will be on the basis of the historical data that we have. If this is not given, we will have to test. We will have to change the test. Right now, we are assuming that this is given to us, and then we are going ahead. Right. Now, this Z critical value is dependent on a few things. What are these few things? Let us know that first. This Z critical is dependent on my confidence level. Confidence level. How? I want you to remember the example that I was giving earlier. So I am 100% confident that the age of BGP Bharat is between 0 to 100. I am 100% confident. Why am I 100% confident? It's because the range is too high. If I want to be more confident, I will have to increase the range. Right? If I am less confident, the range will automatically come down. Right? Or if the range is coming down, my confidence level will also come down. Think of it like this. I am 100% confident that the range of your age, the age, mean age in this class is 0 to 100. I am 100% confident. I want to decrease this range. And I say that the range or the age, mean age in this class is between 28.6 to 28.8. You think I'll be 100% confident still? My confidence level will obviously go down, right? So range is going down, confidence level is go down. In order to increase the confidence, your range will go higher. Now, you will see the same thing here. Right now, what is the range? The range is from here to here. If I want to increase the confidence level, right, I am 95% confident. 95% confidence means Z value we know is 1.65. Right? If I want to be 100% confidence, I will have to have a Z value of almost 3.9999. Remember? In the table, 3.99 used to give us 100% confidence. So my range is going up as my confidence level is going up. But I don't want to go till this point. I want to have only this. So I am 95% confident and I want to stay with 95% confidence level. Right? Generally, we stay with 95% confidence level.
What's the Z value that you're getting? Where is the starting point for that?
Here, 0.
That is, but sometimes it's also in minus.
So if I'm talking about this side, if I'm talking about this side only, then it will be here to here. Right now, I'm saying 95% confidence level means starting from here to here. This is 95. This area is 95. That is why we are starting from 0. That is why we are starting from 0. Right? Whatever is left is what? 5%. If I'm covering 95, then I'll be left with only 5%. Now I just want to find out the Z critical value. How much is this value if I am in a standard normal distribution? Where do I get this 95 area covered? So I get this 95 area covered at 1.65. Let's see, calculated from the table. Now I know that, okay, in order to be 95% confident, in order to cover 95% of the area, this value has to be 1.65. As soon as I get to know that this is 1.65, I can now do multiple things, and I want you to focus now. For those of you who have not got it, you will get it now. Now, this is a gold standard for me at 95%. I know that at 95% confidence, my Z value is 1.65. Now, I will compare this particular case with this. This is from a standard normal distribution, 95% confidence level. I want to see that what is the Z value of this particular problem. How do I calculate it? Formula is simple. Z calculated is equals to x bar minus mu upon sigma by. And I calculated that from this, my Z calculated value is coming out to be 10. 10 means what? 0, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7, and 10 will be somewhere here. Right? Which is in the rejection region. So I am not featuring in the acceptance region. Why am I calling this as acceptance region and why am I calling this as rejection region? If the Z value would have been lesser than this, I would have said that this claim that it is 70 is true. Because I don't really care if it is 0 to 10 to 20 to 30 because then it would have been true. I am saying that till 70 also I am saying whatever they're saying is true. I am ready to go a little more than this. Why? Because of the sampling error that is possible. How much is this tolerance? I found out 0.33. So even if the X bar value comes out to be 70.33, I will say that okay, whatever you are claiming is true. If it goes beyond that, my friend, if it is 70.35 also, I will say no. This is not because of the sampling error. There is something wrong with your claim. The claim is not true. And that is how I reject the hypothesis that mu is equals to 70. Right?
So here the Z value starts from 0 at that moment.
Sorry?
When we calculate Z value, that starts with 0, the mean as 0 point.
Okay. So here the Z value is 0. Okay. There are two things. Okay. I get your question. There are two things. Z value is here 0. Z value is negative here. This is Z value. This is also Z value. This is also Z value. Z value will go to negative 0.3, 0.99 something. Here it will go to already 3 point something. When I said 0, this is probability. So 0 to 95%.
That is the probability.
Yes, 0 to 95% is the probability. So here the probability is exactly hitting 95% at z value of 1.65. At z value of 0, when z is equal to 0, the probability is 50%. Similarly, when z value is 1.65, the probability is 95%.
So if it is, even if z value is in negative -2 or something, the probability will still be maybe below 50% is
Yes,
what?
but it will be there. At z is equals to, let's say, minus z value of minus 1.65, probability is 5%. Right? Is this okay? This is one way of doing and looking at things. There are multiple ways of looking at things. Another way of looking at things is that I don't want to use d and all. I just want to find out what is this number you tell me for this particular distribution. So for this, I found out that this is 70.33. That is also possible. There's one more way of looking at it. What is that way?
So sir, when you say 70.33 now, so that means 72 that we have taken out is in the rejection
So
phase.
yes, because it is beyond 70.33.
So what Dyson is claiming is that if you are taking any sample and you are getting your mean more than 70.33, your sampling is biased.
No. What Dyson is claiming is Dyson can't tell that. Dyson can't raise questions on my employees or the way I've collected data. भाई आप हो seller. आपका काम है 70 से नीचे बेचना. आप ये शिकायत नहीं कर सकते कि आपने सैंपल जानबूझ के मेरा फेल किया है. ये तो आप ये क्लेम कर सकते हो कि भाई मेरा जो प्यूरिफायर है वो 70 की 70 का AQI मेंटेन करके रखता है. अब मैंने सैंपल लिया, आप फेल हो गए. अब आपको रोना ही पड़ेगा. अब आप कंप्लेन नहीं कर सकते वापस. What Dyson is claiming and what Dyson can claim is that my AQI level is 20. Right? We collected a sample and we showed Dyson that it is not. What we are saying is if the sample AQI, if the sample's AQI is below 70.33, anything below 70.33, Dyson is saying true things or Dyson is saying the truth. But if it is beyond 70.33, then Dyson is lying that it is 70. It is not 70. There is a systematic problem with the product. Yes, sir.
Questions. Well, the 70.33 you inferred back from the z value, right?
Yes.
In the z value,
Yes.
the actual value at that z.
Right.
Second, when you say the z critical at 1.65 is a 95% probability of what?
Both the questions that you asked are interconnected. Hold your question for something. I wanted to be 95% confident that the test that I am doing is right. So I am saying that, okay, I am right now 95% confident with this particular value, which is 70.33, that the bias is controlled. So if I will do it 100 times, even if Dyson's claim is 70, out of 100, 95 times, it should be below 70.33 to accept their claim. To accept their claim. Out of 195 times, there is still a 5% probability, and I accept that 5% probability that I might have done something wrong here. And Dyson would have been actually true, and I am saying that they are not true. And I am 95% confident that whatever I am saying is true, and it is whatever Dyson is saying is wrong. I am only 95%, but 95% Dyson will also have to accept because that's the industry standard. Right? That is first thing. Second thing is when you say that this number 70.33, it is coming on the basis of the Z critical value. Yes, absolutely. That is why we are saying that if I want to be more confident, so right now I'm 95. If I want to be 99% confident, then the Z critical value will increase. Then this 70.33 will go up to 71, 72 also. But 10 is still very, very far. So Dyson का तो जो value है तो फिर भी possible होगा ही.
You're saying out of the 100 tests you run, 94 times it might be below 70.33, but 1% तो है कि
नहीं, ये नहीं है. If I am doing this test 100 times, अब मैंने इसका ये ऐसे भी समझ सकते हैं मैं 100 का सैंपल 100 बार ले रहा हूं. I am collecting 100 such samples. Out of 100, 95 times this claim will be falsified.
Will be above 70.
It will be above 70.33. 5% times it might be there also.
If it's below 70.33 more than 5% of the time.
वापस बताता हूं.
If it's below 70.33 more than 5% of the time, the claim is valid.
No. Then their claim is not valid. My confidence level is telling how many times it will be rejected. How many times it will be beyond that. देखिए, किसी एक ही स्टेटमेंट को समझने के और बोलने के बहुत सारे तरीके हैं. One way of saying it is, in fact, I'll show you a diagram to make it more clear. And that diagram is talking about this particular thing only which you're saying. Look at this. Look at this. This is the confidence level that we are talking about. So when I say that Dyson is saying that their mean is 70, right? Please pay attention. When you're saying that Dyson is saying that their mean is 70, I am taking 100 samples. I am 95% confident that this is true. If this is true, it is actually 70. Then out of 100, 95% of the times, that is 95 times, it should be in that range. If Dyson was true, that it is 70, 95% of the times, the value should actually be below 70.33. Now it is not coming out to be below that 70.33, it is going to 72. That is why I am saying that what Dyson is saying is false with 95% confidence. Now, these two are same things. इसको ऐसे समझिए कि आप एक निशाना लगा रहे हैं, आप एक निशाना लगा रहे हैं कहीं पे. If I am throwing this pen on the bottle and I say that I am 95% confident that it will hit the bottle, it means that if I am throwing 100 pens, 95 will hit the bottle. If I am throwing it once, I am 95% confident that it will hit the bottle is equals to throwing it 100 times and 95 of them hitting it. When I say 95% confidence level, I say that if I do it 100 times, 95% of the times it should be below 70.33. In the case where I did this test, it is going beyond. So I say I reject it. Now Dyson can only say, आप तो 95% ही श्योर हो. ये वाला जो केस आया है, ये 100 में से जो 5 वाले केस है, उनमें से एक है. That is what they can say. But what will I tell them? That I am 95% sure that this is not that case. This is 95% true. And what you are saying is actually false.
Then you run more tests and make sure that 95 पे you have more data.
So there are multiple ways of saying the same. Dyson will also say कि आप 5% में आ गए हो. मैं बोलूंगा मैं तो 95% में हूं. Right? So that is what we are saying here, the 95%. And what I am saying is that if you, and there's another way of doing it, and please don't be confused, just one simple thing I will do here, which is that around this 72, what Dyson is getting is this 72. Dyson को यहाँ पे 72 आ रहा है ना. I can form a 95% confidence interval around this 72 also, which will be अपन को ये पता पड़ गया कि 0.33 है, तो 72 से 0.33 तो इधर आएगा ज्यादा से ज्यादा, which is still way beyond my level. So I will say that whatever this is not by chance. This is way too, on the higher side. So what you are saying is false.
Calculations का भी
Calculations पे देना भी नहीं है ध्यान, because Excel will do the calculations for us. हाँ जी. Okay. So just to summarize, I want all of you to listen now. Just to summarize.
just before you say जब सिग्मा पूरी डायसन ने दिया है 70.33 ही क्यों
डायसन तो ये बोल रहे हैं कि भैया ऊपर नीचे हो सकता है, 2 स्टैंडर्ड डिविएशन आ रहा है. नाउ दिस इज
का तो उसका मतलब यही हो ना कि 68% यार कॉन्फिडेंस है मेरे को कि 68% केसेस इसमें आ जाएंगे 72 के अंदर. 95% 70.33 पे क्यों आ रहा है?
देखिए, when you talk about samples, right? What they are saying is population standard deviation. What they are saying is कि मैंने हजारों बनाए, उनका है ये standard deviation. और अब आप उसको लेके दो, और अब आप उसको लेके आना चाहते हैं sample में. You are talking about sample. The standard deviation of the sample might be very, very different. It is possible that the standard deviation of the sample that you have collected is almost zero. Possible. जैसे इस क्लास का स्टैंडर्ड डिविएशन हाइट का लेट्स से इज 0.5, 6 इंचेस इज द स्टैंडर्ड डिविएशन ऑफ द हाइट. नाउ आई पिक 3.
आप फॉर्मूला में तो 2 यूज कर लो फिर. आप जो सैंपल का यूज, अगर सैंपल की बात हो रही है फिर सैंपल का स्टैंडर्ड डिविएशन यूज होना चाहिए.
बिल्कुल सही बात है. जब हम v टेबल यूज करते हैं, v टेबल में बिकॉज वी आर गिवन दिस गिव्स अस अ बेटर एस्टिमेट ऑफ द पॉपुलेशन. When we don't have this, then we use sample standard deviation only, which is S. What you are saying is, what he is saying is, why are you using sigma? Because you are talking about population and then you are collecting sample. You are talking about sample and then you are considering the statistic from the population. This is the question. The reply to that is that the sample, where is the sample coming from? Population. It should be a representative of the population, right? As the sample size becomes large, larger, the sample standard deviation should approach the population standard deviation. ये होना तो यही चाहिए. धीरे धीरे सैंपल और पॉपुलेशन का बराबर हो जाएगा जैसे ही मेरा सैंपल साइज बहुत बड़ा हो जाएगा. तो बात तो यही है कि मैं एज अ प्रॉक्सी I'm using sample standard deviation if I don't have that. But if I have that, that is better. Right? ये ऐसे समझ लीजिए डीएनए है. अगर आपका इंसान जिंदा है तो आप डीएनए सीधा इंसान से ले लेंगे. अदरवाइज नहीं है इंसान अवेलेबल तो फिर आप बाल ढूंढते रहते हैं, खाल ढूंढते रहते हैं. तो अगर आपके पास में इंसान है तो फिर आप उसको, so you have the population standard deviation, why would you use a proxy? That is a better measure and estimate, right? That's why.
My basic issue is that when a standard deviation says that 68% of all the cases, whatever you're going to collect the data, is going to exist within the +2, -2.
Right.
Correct. So why is 72 out of bounds?
ये वाला आंसर जो है वो आपको मिलेगा इस वाले डायग्राम से जो मैं अब बनाता हूं. आप जो बोल रहे हैं, आप समझिए कि आप बोल रहे हैं 68% यहां से यहां के बीच में मेरे दोस्त, और जो हम बात कर रहे हैं, जो हम बात कर रहे हैं, the thing that we are talking about is this. Are these two same? These two are not same. We are saying this is 95.
Start left back.
You are saying this is 68. And this is not a uniform distribution where the things will become, this is not a distribution like this where this and this, if the width is equal, will be equal. In a normal distribution, the things will be very, very different from here to here versus here to here. If this width is, let's say, 2 centimeter, and if this width is also 2 centimeter, the area covered here will be much, much, much larger in comparison to this. So the area covered from this to this will be very, very different from the area covered from this to this. इसको मैं आपको एक और एग्जांपल से समझाता हूं. 95 के ही एग्जांपल से समझते हैं. यहां पर 95 में हमारा कहां से कहां पे z वेरी किया देखिए, -4 से लेकर के 1.65 तक. So this range is how much? 5.65 का रेंज हो गया ये तो. Whereas when you talk about 95% confidence level, याद है -2 स्टैंडर्ड डिविएशन में आ जाता है वो. तो यहां तो 4 का ही रेंज में 95 कवर हो गया. Are you getting my point? Here you say no, you were saying that this is -1 standard deviation to +1 standard deviation, 60% of the area is covered. The range that we are talking about is what? -1 to +1 is how much? 2. If you talk about -2 to +2, the range is 4. In this 4, you are covering 95% area. But when you start from here, the range becomes 5.65. That is why it is not equitable, and that is why you cannot think of this exactly like this.
Are these two different graphs altogether? Like,
No, these are not two different graphs, but then this is a graph which is not a uniform or a very standardized graph. Uniform or standardized, well, it's not a very well defined. ये जो इसका curve है ना bell, this in itself is making things complex. If this would have been a curve which is like this, यहाँ पे straight होता, तो फिर जो आप बोल रहे हैं वो मैं मानता. सोचिए, सोच के देखिए. If this would have been a curve where the probability is remaining the same everywhere, then I would have agreed to this. But then this is not a curve where the probability is remaining the same. The probabilities are changing.
Asking sir, ये 68 वाला जो 95 वाला आपने बना रखा है, इन दो कर्व्स में क्या फर्क है फंडामेंटली?
इन दोनों कर्व्स में कोई फर्क नहीं है, इनके रेफरेंस पॉइंट में फर्क है. आपको ये समझना पड़ेगा. Are others okay with what I am saying, or is this doubt for everybody?
No,
Let me take it offline. If this time it is this curve is exactly the same as this curve, let's say. These are absolutely same. It's superimposable images. The area covered from -2 to +2, or let's say -1 to +1 in fact, which is in a range of how much? 2. ये पूरा का पूरा जो the distance is 2. This will be very different from -4 to 0. यहां पर भी आप बोलेंगे कि डिस्टेंस तो -4 to -2 in fact, not even 0. -4 to -2. यहां पर भी रेंज तो 2 ही है, यहां पर भी रेंज 2 ही है. But the area covered here will never be 68%. Area covered here is 68%. Why? Because you are talking about the most dense area. Here the area is not that dense. क्योंकि ये कर्व चढ़ने लगा है, यहाँ पर ये इसकी स्टार्टिंग है. हर 1 सेंटीमीटर पे the area covered will be more and more and more. That is why when you are saying that it is already been said that this is 68%, इतना तो आप क्यों नहीं मान रहे हो? मैं इसलिए नहीं मान पा रहा हूं क्योंकि the reference points are different. Here the reference point is this and this. Here the reference point is from 0 to this. That is why it will be different. That is why we are not able to consider this. Even or upon after the class we'll discuss it. Right? Now, if this is okay, I want you to look. So okay. Now coming back and talking about the things again. This was the hypothesis lesser than equal to rejection region will only be on the higher side. Right? We found out the Z critical value. You can compare the Z critical value with the Z calculated value. How do you calculate the Z calculated value? Given whatever the data is given, on the basis of that you find out Z calculated, and then you compare the Z calculated to Z critical, and then you take the decision. That is one way of doing it. Other way of doing it is you can find out with this Z critical what will be the associated X bar value here, and then you can find out this X bar and you can compare this X bar with this. This is the second way. There is a third way also, which is known as the P approach. So this one is known as a Z approach. This is a Z approach. And then there is one more approach which is known as a P approach. What happens in a P approach is you say that, okay, what is the value of Z here? 10. We calculated as 10. I want to find out the probability at 10. If you go to the Z table, though there is no value given at -10, or sorry, 10, the table ends at 3.9, but you can easily, looking at the table, you can easily tell that the value will be very, 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 very high, 0.9999999999 something. So the area left will be 0.00000000000 something, right? So this is way lesser than 5%. So what do you compare is alpha and P. Alpha is your 5% value, which is 0.05. P is what you are getting at the Z value of whatever you have calculated, Z calculated. Calculated. In our case, the P value is coming out to be 0.0000000 something. Right? So if P less than alpha, reject H naught again is what you. So either you look at Z critical and Z calculated, or you look at P and alpha value, and on the basis of that you define. Let us very quickly do a few questions, and then the things will be even more clear if they are already not clear. Okay, the critical values are clear. Everything beyond the critical value becomes the rejection region. Everything within the critical value becomes the acceptance region or non-rejection region. Now I want you to look at this particular example which is here. Right? You want to test the claim that the true mean diameter of a manufactured bolt is 30 mm. Where the bolt, क्या हुआ? सब लोगों को वैसे हो गए. You want a break?
Yes.
Go. But come back as soon as possible. Okay. Let us do a few questions quickly. We will do a few questions and
तो the shift मार ले.
so if this is clear, right? I want you to look at the question and now onwards, whenever we'll be looking at the question, I will not. I will assume that a few things are clear and I will ask you and you have to answer, okay? Read the hypothesis. Read the hypothesis in this question. Test the claim that the true mean diameter of a manufactured bolt is 30 mm. Now, what is it that you have to test? Test the claim that the true mean diameter is 30 mm. What is the hypothesis?
Equal to.
Is equal to, right? Because it is 30. If it is equal to 30, it's a one tail or a two tail test. Two tail test. Also, if I tell you that suppose that alpha is 0.05, two tail test with the area under one tail will be how much? Two tail test at 95% confidence, alpha value is 0.05. How much is the area under one tail?
0.025.
0.025. Also, you are told that n is 100. Right? Now, n is 100 means you have taken 100 bolts. Now, 100 bolts are taken. Confidence level is 95. It's a two-tailed test. What you get is for these 100 bolts, the X bar value comes out to be 29.84. Possible?
Yes.
आपने 100 बोल्ट लिए उनका एवरेज देगा 29.84 आ गया. Also, you are told that the sigma value is 0.08. The company knows, इधर ही लिखा हुआ है, assume sigma is point. The company knows historically that the population standard deviation has been around 0.8. Now you have to test whether this is true or not. How do you do it? Simple. L is the data available, right? N is equals to
100.
sigma is equals to
0.0.
mu is equals to 30. X bar is equals to 29.84, right? Also, alpha value is told, which is
0.025.
0.05. I know it's a two-tailed test where the hypothesis is this. In a two-tailed test, what does my diagram look like? My diagram looks like this. This is the rejection region on both the sides. Both the sides it is 0.025. 0.025. I also know the Z critical value. Z critical. Z critical on the positive side is 1.96. On the negative side it is negative 1.96. Till this side, till this point, everything is clear. Now we just need to find out Z calculated and compare it with Z critical. Calculate Z calculated, fatafat. Z calculated will be X bar minus. What is X bar minus mu? 29.4 minus 30. 29.84 minus 30. Minus
0.16.
Sorry.
Minus 0.16.
Minus 0.16. Correct. Divided by sigma by root n. Sigma. 0.8 divided by root of 100. 0.8 divided by 10.
0.08.
0.08. 0.16 divided by 0.08. 16 by 8. Negative 2. What you're getting is negative 2. Where will negative 2 be in this? Negative 2 is inside this or outside this? Outside this. So you get negative 2. So you will say reject H naught. That means you're rejecting this, which says that mu is equals to 30. So your conclusion will be that the diameter of the bolt is not 30. Right? We can reject the claim and can say that this is not 30. One way of doing it. The other way of doing it is, once you have found out this minus 2,
1.96.
you go to alpha value at minus 2. What is the alpha value? Oh, sorry. Once you've got this minus 2, Z is minus 2. Find out the P value associated with this minus 2. I know for a fact that this is 0.227. Right? Now, if this is P is 0.227, I will compare it with alpha value what? 0.25. Right? This P is lesser than alpha, yes or no?
Yes.
P is less than alpha, 0.022 is less than 0.025. P is less than alpha, again, reject H0. Another way of doing the same thing, the result will always be the same. It will never be different from what you are getting from this. But then the only thing is that the way you are looking at things is different. You can do one more thing, which is at this V1.96, find out the critical value. Right? Can I do it quickly? I know that this is 1.96 negative is equals to x bar minus mu upon sigma by root n. Now, you know sigma by root n was coming out to be 0.08. X bar minus 30. Do this 1.96 multiplied by 0.08.
1.568.
Sorry?
0.156.
1568.
0.1568 negative. Because this was negative. Right? Is equals to x bar minus 30. X bar value will come out to be 30 minus 0.1568. So x bar will be
9.84.
29.8432. In this case, what you got was 29.84. तो आप सिर्फ 0.32 से चूक गए. Right? Got understood, right? सिर्फ 0.32 से चूक गए. आपका यहाँ पर क्रिटिकल वैल्यू आता 29.84 समथिंग और यहाँ पर आपका कुछ आया 29 point something. You've done this correct, right? That is why you will see negative 2.0 and negative 1.94 is very 1.96. Very close anyways. Will you do one more? ये देखिए यहां पर इन्होंने निकाल के भी दिखाया है कि अगर 95% कॉन्फिडेंस इंटरवल में जाना है with 29.84. Now this is again a way where we are saying that what we are getting from this, and I was telling you, there are multiple ways of interpreting this. In this one, what they're saying, or what we are saying is, I am now drawing your samples distribution. आपका सैंपल का डिस्ट्रीब्यूशन बना रहा हूं मैं. सैंपल का मीन वाज 29.84. Right? Sigma value I am assuming 0.8. I know that is equals to 100. Right? I am finding out this 95% confidence interval बीच से. In this 95% confidence interval that I get, my values are coming out to be 29.68 to 29.9968. 30 is not covered in this. 30 is outside this. That means that if you will be considering 95% confidence interval of your sample also, it will not be touching the claim. बात वही है. अगर आप मेरे से 1 arm distance पे हो तो मैं भी तो आपसे 1 arm distance पे हूं. तो अगर आप मेरे से दूर हो तो आपसे मैं भी दूर. That's the only thing that we are saying here. And if you will notice one thing, how much is the difference of this from 30? कितना distance है ये? 32. 0.0032, right?
Yes.
वही तो आपने भी यहाँ पर कैलकुलेट करके बताया था भी मुझे. Where was it? We just did the calculation.
Right.
तो हमने बोला था कि आप बस 0.0032 से चूक ये वाला 0.0032 से तो चुके थे आप भी 0.8432 आ रहा था and the question was 0.84. So it is the same thing, same distance from each other. Okay. Now comes the next point where we are now going ahead with the version where we are saying that we don't know the population standard deviation, which is more realistic in nature also. एक क्वेश्चन ये था कि आ कहां से रहा है सिग्मा आ ही गया तो दिक्कत ही हो गई. फिर तो आपको सब कुछ पता ही है. तो हम बोल रहे थे कि भाई सिग्मा आ रहा है पॉपुलेशन स्टैंडर्ड डिविएशन हिस्टोरिकल डेटा से, राइट? कंपनी मैन्युफैक्चरर इज टेलिंग अस दिस एंड दैट. देन द क्वेश्चन वाज if Dyson does not tell us this particular statistic sigma, then what do we do? Then I told you that if they don't tell us, we will get it from the sample. Now we will get it from the sample, and instead of using Z, we will be using T test, and instead of sigma, we will be using S. Nothing else is changing. Nothing else is changing. Only one thing is changing. Instead of x bar minus mu divided by sigma by root n, I am now writing S by root n because I don't know what this sigma is. And because I don't have this sigma, the distribution that I was doing, Z, was a distribution which was for the population. I cannot use this distribution also. I will have to use a T statistic or a T distribution, T table. We did it in the last class also, right? T table. Let us now do this question. Let us now do this question. Read the question, please. Sorry.
We'll be done in 5 minutes, 10 minutes. 10 minutes? Sir, classmate only. He has come now. Without going down at 10.
Okay, please read the question.
Don't come, I'm saying we'll come down.
The mean cost of a hotel, room in New York is said to be $168 per night. अभी बताओ क्या बोला वो? Mean cost of a hotel room in New York is said to be 168. It's said to be at least 168, at most 168. कुछ बोल रहा है? Said to be 168 equals to 168. So hypothesis to mu naught is equals to 168. Mu alpha mu 1 is not equals to 168. ये बन गया है. To determine if this is true, अब ये पता लगाना है कि आपके एक दोस्त ने बोल दिया कि अरे न्यूयॉर्क में तो $168 $168 का $168 का होटल है. Now to find out whether this is true or not, you draw a random sample of 25 hotels. Now, 25 hotels that you have taken, so n is equals to 25. For these 25 hotels that you have taken, x bar is coming out to be 172 point. This is x bar, okay? Can you find out where the bar is? So x bar is 172.50. And there's an S value also given which is 15.4. What else do we need? That's it. Alpha value is
0.05.
0.05. You know that it is a two-tailed test. If it's a two-tailed test, right? So alpha by 2 will be 0.025. Now I want you all to remember the T table. In the T table, you used to have a degrees of freedom. Degrees of freedom will be
24.
24, which is n minus 1. So now in order to use the T table, we will be looking for degrees of freedom 24. And what are we talking about? One tail is 0.25, 0.025. चलो T table देख के आ जाते हैं. पहले critical value निकाल लेते हैं. So we'll find out T critical first. Let us look at the T table. Degrees of freedom is what? 24. So you're talking about this particular row. And what is the one tail?
0.02.
One tail is 0.025. This one. Right? In both the tails together, you are talking about 0.05. यही वाला तो है ना? इसमें आ जाते नीचे 24 को ढूंढने. Where is 24? Where is 24?
2.064.
2.064. So T critical becomes 2.064. 2.064 is T critical. Let us find out T statistic quickly. What is T statistic? The formula all of you remember?
70 bar minus.
T statistic is equals to x bar minus mu upon s by root n. X bar is 172.5 minus 168 divided by 15.4 divided by root of 25, which is 4.5, right? Divided by 15.4 divided by 5. So 5 3 is 15, 3.08.
8.08.
Yeah. Accepted.
This will be what? 1 point something, right?
1.46.
Almost 1.5. Yeah.
So this is 1.46. Now you have this. Now you have this. Where you are saying T critical value is 2.064 and the value that you are getting, sorry, 2.06. And what you're getting is 1.46. 1.46 is within this. So what will be the conclusion?
It's true.
Not-
Do not reject. Don't say accept, do not reject. So you say do not reject H naught, which means that H naught is this, where you will say that you do not have enough evidence to reject the null hypothesis that it is 148, right?
Acceptance cover.
How do you write? See, insufficient evidence. How are you? I want you to read the, first of all, see whether what you've done is true, correct or not. Wait, right, okay. T value is at degrees of freedom 24 and 0.025 was 2.064, we were saying 39 can be. And then the calculation is 1.46, which you did is absolutely correct.
Yes.
And then you say insufficient evidence that the true mean cost is different from this. Right? Lower tail, upper tail, I've told you. Same way, I just wanted to do this quickly. A phone industry manager thinks that customers' monthly cell phone bills have increased. Right? So let's say Airtel is saying that the monthly bills have gone up and are now averaging over $52 per month. What is this? Over 52.
Greater than
Over 52.
Greater than.
It is higher than 52 or equal to 52 or lesser than 52 or higher than 52. What is it?
Higher.
Over 52.
Higher.
Higher. So if you're saying it is higher than 52, what are we talking about? Is this a null hypothesis or an alternate hypothesis? Alternate because there is no equal to sign. And what will be the null for over 62? Lesser than or equal to. So the hypothesis here will become that mu is less than or equal to 52 and mu is greater than. This will become my null and this will become my alternate. Right? The company wants to test this claim. Now we need data to test this claim. Let us see the data that is given. So you're given n value of 25. You took sample from 10 people and the sample's average is 53.1. You will put this in the testing happens in the same manner. The statistics remain the same, nothing changes. Right? You're getting 0.55 from here. Then what will you do? Degrees of freedom 25. Oh, sorry. N is 25, degrees of freedom will become 24. And if you are given the alpha value, so in this case the alpha value is different. See, it is not 95%.
90%.
What is happening is it is 90%. And because it is a upper tail test, see this, upper tail test, right? It is upper tail test, you will have rejection region only on the higher side. At 90%, you can find out this critical value. Right? चलें एक बार देखिए Z table में T table में देखिए. What are we looking at? Degrees of freedom?
24
and alpha value is 0.10. Degrees of freedom is this 24 and we are talking about one tail being 90.1. Okay, one tail 0.1. So 0.1 and then 24. 1.318. 1.318 is a T critical value. And then you find out the T statistic value. And if the T statistic value is more than 1.318, reject. If it is less than 1.318, do not. So it is less than this, so do not reject. Do not reject means what? This is interesting. Why is this interesting? Do not reject null. You are not rejecting null. Means this is true. Means that this is lesser than or equal to 52. Means whatever the manager was saying is false. Right? Okay. We have 5 minutes. I'll just stop. No more maths, nothing. Just 5 minutes. Because we've been a little I wanted to finish this thing, but I'll just talk about this thing. Very, very important. Huh? I can take 5 minutes.
So all this calculation, we can do it on Excel.
You will not be doing it by hand, okay? We'll do it on Excel only, but towards the end. See, actually, I'll tell you.
So can you go back to the problem? Read the statement.
Whatever we have done now is known as one and this one, right? This one. Now I'll tell you something. Till this point, we were, and again, very important discussion, last 5 minutes, pay attention, very important. Till this point, what we were doing was child's play, sort of. Why? Because you were comparing your hypothesis, you're talking about the hypothesis with respect to a specific number. आप बोल रहे हो कि monthly bill has gone up from 52 or not, whether the diameter of the bolt is 30 or not, right, is exactly 30, whether the air quality index is 70, you're talking about a number, right? But does it happen like that in marketing in real life? Or let's say any other thing, right? Let's say I am a drug as in medicine company. I am a pharmaceutical company. I have created a new medicine for treating fever, right? And I say, if you will take my medicine, your temperature will go down. And my medicine is better than the other medicines out there in this country. अब मैंने तो कोई नंबर नहीं बोला यहाँ पे, मैंने तो ये भी नहीं बोला कि भाई अब मान लो ये भी बनाते हैं दवाई, मैं भी बनाता हूँ दवाई. I am not told by how much. I could say that my medicine will make your temperature go down more than what his medicine is doing, right? One case. Another case is, let's say I am an advertisement company. I say that I will release an advertisement for you. Whatever advertisement you will watch or your customers will watch, after that their perception about your company will be significantly better. I did not tell by how much. It will be better. Now, in these cases, what do we do? How will we test such hypothesis? Right? And hypothesis is a testable statement. So I need to test this statement. The difference in this and the previous case that we were looking at was that the previous cases were all with respect to a certain reference number. 70, 30 or whatever. In this case, there is no reference number as such. There's a reference point, but then another sample. So I have two samples now. One sample is from his company, one sample is from my company. Right? Whenever you have such cases where you have two samples to compare, you call it as a two-sample hypothesis testing. Whatever we have done till this point is one sample hypothesis testing, one sample Z-test, one sample T-test. ये इतना सिंपल है कि एक्सेल ने भी उसके लिए कोई ड्रैग एंड ड्रॉप बटन नहीं डाल रखा है. Right? But now onwards, the things will become complex and you will be able to do these things on Excel. If you don't realize that things will go complex, I'll show you the formula. Right? So we don't want to do all this, obviously. I don't want you to do this. I don't want you to look at the formula also. That's why I'll not do it in the class also, because we have option of solving these on Excel directly. But for the one sample t-test and all, Excel also does not have. Because what are you doing anyways? Excel क्यों बनाएगा? उसने फॉर्मूला बना रखा है ना, norm.dist तो यूज कर रहे हो एक तरीके से. Now, I want to talk about last concept, which is a paired and an independent t-test. Right? There are two kinds of t-test when you have two samples, and 2 more minutes I will take, but with attention. Paired t-test, as the name is suggesting, paired or dependent. There are two names for it, paired or dependent. Paired t-test is a t-test where the data is collected or the sample is the same sample before and after the treatment. Before and after the treatment. For example, I want to test whether my medicine is working or not. Let's say I have prepared a medicine for cancer. Now I want to see whether my medicine is working or not. What will I do? I'll take a sample of, let's say, 100 cancer patients. I'll give them my medicine. and then I will see whether the cancer has been cured or not. Same sample before and after. I am saying that I am a advertiser. I prepare marketing campaigns of whatever sort. I want to see whether the impact is there on people's mind or not. I make you sit in this class. I ask your perception on a specific company. Let's say toothpaste. Let's say Colgate. I ask you to rate Colgate on a scale of 1 to 7 on, let's say, healthy toothpaste. You have given me your feedbacks. I take it with me and then I show you an advertisement. मैंने एक advertisement चला जिसमें I'm showing you how Colgate is made, and I'm showing you that the very hygiene and highly, the factories sanitized properly and the way they do it is very good and all these things and all. And then I ask you to rate it again. If there's a significant increase in your rating, let's say earlier you gave me 4.1, now you're giving me 5.8, right? I'll be able to say that it has worked, the advertisement has worked. But before and after the same population, I've not changed the population. I want to see whether my course has added any value or not. We did a quiz in the very first class before we started studying. Then I will do a quiz at the end after we have all studied and all these things, right? And then I will see whether there's a significant change in the marks average or not. Before and after. Before and after is clear. Paired or dependent t-test. Then you have independent t-test also. What is independent? Where I have group 1 and group 2. For example, group 1 and group 2 is in this class. Assuming that the students are homogeneous, all are similar students, right? I want to see if I teach statistics using PPT versus I teach statistics using games. Is there a significant difference in learning or not? So I create 2 sections, group 1, group 2. To group 1, I am teaching using PPT. To group 2, I am teaching using games. And then I give them the same question paper after the end of the course. And then I compare whether there's a difference in their marks or not. Right? I take 100 fever patients and I give them my medicine. I take 100 fever patients and I give them his medicine. And then I compare. Average temperature before, initially both of them, let's say both the groups had average temperature of 102. Now who has gone down further? His medicine is working. So is there a significant difference in group 1 or group 2 is what I am interested in. Independent. These groups are not dependent on each other. These groups are independent. That is why, if you will see on your screen here, you have 2 sample tests where the population means are independent samples. Independent samples means group 1 versus group 2. And then here you have population means related samples. Related as in before and after the treatment. Paired t-test, unpaired t-test. Right? Okay. Also, if, and the basic rule remains the same, if population standard deviation sigma is given, you go ahead with t-test, 2 sample. If population standard deviation sigma is not given, you go ahead with t-test, 2 population. Right? We'll do this on Excel in the next class, hardly 5 or 10 minutes. The interpretation remains the same. The way you analyze remains the same. P less than alpha, reject null hypothesis. It becomes, after you'll go home, you will do all your musty fun and you will forget the rule. So I'll tell you easy way to remember. P is low, null has to go. P is low, null has to go. P less than alpha, reject that's not. P is low, null has to go. Why am I saying this? Because now onwards, we will not be drawing and seeing where is C, where is P, oh, it is in the rejection region and all. We won't do that. We'll just look at the output of Excel and we'll see our Excel output is P value 0.028, reject. P value is 0.04, reject. P value is 0.08, do not reject. Assuming that 95% confidence interval is what we are talking about. And we'll keep talking about this in regression also. Regression is also based on hypothesis testing. So in the next class, we will do the 2 sample tests and regression. Okay. So now next class will be an extra class. Yes. So because you know that we have already done 2 quizzes. So there's one more quiz that we have to do as promised. So you all know that in the next class there will be a quiz for sure. Right. So this is surprise announced quiz. And the syllabus will be confidence interval and hypothesis testing that we will be covering, and regression that we'll be covering till the end of the next class. तो आप यहाँ तक का तो प्रिपेयर करके आएंगे, उस वाली क्लास में जो पढ़ेंगे वो भी आ सकता है, एंड यहाँ तक का प्रिपेयर करके आएंगे मतलब कि कौन सी स्लाइड नंबर 297. अब तक तो भूल जाएंगे.